And ladies and gentlemen, please welcome to my talk with the topic, how well can a low-cost camera's image quality compete with an iPhone 15? And to give you a little bit more feeling about this topic, I want to start with my daily life. So the company Helpling, we are an R&D contractor. We are located in Switzerland with more than 500 engineers. And in our daily life, we have a wide service portfolio for product innovation, product development, until the industrialization of the products. Most of the 500 engineers, they have a background with mechanics, electronics, and software. And there's one team dealing with optics. That is my team. So we are 15 engineers, optical experts, vision experts, and we have two kinds of customers. On the one hand side, customers from the optics industry, and on the other hand, we have customers without any optical knowledge. And for this group of customers, we are an enabler. We enable them to integrate an optical system or vision system into their products. And from these types of customers, sometimes we hear the requirement, we want to have an image quality like an iPhone or like a mobile phone. But on the other hand, as I mentioned, they have no idea about the optics, and I think if you call Apple and you ask them, can I get the camera module from the iPhone? I'm not sure if they agree. So, yeah. And in addition, we have an optics lab. In the optics lab, we have good measurement possibilities to check the image quality according to the ISO 12233. That's about to measure the image quality of a camera system. And so, because of this requirement, of the image quality like an iPhone, we decided, okay, let's check the image quality of an iPhone and of some low-cost cameras. And overall, in the end, it was not only the low-cost and the iPhone, also some industrial cameras. And let's compare them. And a short overview of this comparison is given here in this talk. But to give you a feeling about what we tested, so as a reference, the high-end camera systems we used in Canon EOS R6 Mark II. That's a high-end consumer mirrorless camera. An iPhone X, an iPhone 15 Pro, and a Samsung phone. Then we took some industrial cameras, what we already have in our lab. And then we bought in China some low-cost USB camera modules. As you see, there's the image sensor is given here on the page. And especially for the low-cost USB camera and the industrial cameras, the same image sensor, different price. And wrong direction. Yeah, and we bought some ultra cheap MIPI cameras. Among others, the camera from the Raspberry Pi version 2. It costs around 20 euros. And if you buy the version from AutoCam, you only pay 10 euros here in Europe. If you buy this module at AliExpress, you can get it around 4 to 5 US dollars. And these are all our test samples. And to make a fair comparison, we tried to use the same hardware, the same software, and the same lens. But it was a bit difficult, especially for the lens. there are different mounts of the cameras, CS mount, M12, the iPhone comes with its own lens, but we try to give our best to compare apples with apples. And our test setup, that's in our lab, it's according to the ISO norm. We use a test chart from the company Image Engineering, TE42. It has some possibilities to check the resolution, to check the dynamic range, and to check the color reproduction. We use 2 standard light panels adjustable in color temperature and brightness. For the measurements, we use an illuminance of 1400 lux. We located the camera exactly in the center of the test chart. And for the image analysis, we used the software tool IQ Analyzer X. That's a standard tool, comes from Image Engineering. That's the same company like we bought the test chart. And I think maybe I have to hurry a little bit up. What we test or investigate here for this talk, on the one hand side, we check the resolution with the VisionSTR, and with the resolution we calculate the MTF diagram, that's for the sharpness. Then with the black, gray and white pattern on the target, we check the dynamic range, and in the end we check the color reproduction. The color reproduction, that's the Euclidean distance, so that means the distance between the color of the test target and the color of the image from the camera. And in case of the resolution, the higher value is the better, that means more sharper. In case of the dynamic range, the higher value means a higher dynamic range. And in case of the color reproduction, the Euclidean distance, that means the lower value comes more close to the test target. And let's start with the upper class, so with the iPhone and the Canon. In terms of the resolution, the MTF50 value, that's the value where the MTF curve has exactly 50%. That's approximately the same for the iPhone 15 or for a Canon camera. Regarding the dynamic range, the iPhone is a wee bit better than the Canon, and I think what's quite interesting. Normally, you expect the MTF curve on the lower. That's the standard MTF curve of a lens. So in my study 20 years ago, I learned the MTF value can never get higher than 1. Or 100%. So what happens in the iPhone, so the upper graph? There we have a value nearly at 100 or 1.25. The iPhone uses an edge enhancement filter, and because of this edge enhancement filter, the software filter, the MTF value can get higher than 1. And yeah, the third, I think that's a good screen here on the Vision. The color reproduction, here we give you 2 results. In the middle, that's the test chart, always with 2 patterns, like given on the test chart, like in the image. And on the right, that's the Euclidean distance. That's exactly the value between the target and the camera from the phone or from the Canon. And what I can see here is the Canon is more close to the target, and the iPhone, they tuned a little bit the color more to the more shiny. The red is a little bit more red. So our first knowledge from here is, if you use a Canon, you have quite neutral images. If you use the iPhone, there are some software filters in the back, especially for the edge enhancement, as well as the colors are a little bit more shiny, more stronger. And in the second step, we made an investigation of two different kinds of cameras with the same image sensor, both with a Sony IMX334. The first one is from a German industrial camera supplier, and the second one is from a Chinese company. The first one, we used the standard software from the supplier, and for the second one, there was no software available, so we used the standard Windows driver. And regarding the costs, the industrial camera is around 200 euros and without the lens, and the Chinese camera came for 100 euros including the lens. And so the same image sensor, and in terms of the resolution, the smaller M12 lens from the low-cost camera is poorer than the industrial camera. But the dynamic range, I think that's what we expected, that the resolution is better with a better lens. But the dynamic range in case of the industrial camera is only about 40 dB, and in case of the low-cost camera, it's around 50. So what happens here? In the software and the driver, you have to choose the right value for the black level correction. And for the standard settings of the industrial camera, this value is 0. So it means there's no tuning. There's no optimization of the image. The low-cost camera, there is a black level correction already implemented in the camera itself or in the driver. And regarding the color reproduction, 2 times the same image sensor. And on the upper, we have a higher Euclidean distance than in the lower test image. That means, and that's our interpretation of these values, is we think in case of the industrial camera, that's the raw data of the chip. And in case of the low-cost camera, they do some image tuning in the software or maybe in the Windows driver. We have no idea, but it was the same camera chip, so there must be something in the software. And then on the third slide, the investigation from the topic of the talk. So we investigate the iPhone from 2 slides before with an AutoCam for 10 euros. And this AutoCam, it has only an MIPI interface, and we used from Texas Instruments an eval board with an embedded Linux on it, and we used the standard embedded Linux driver who comes with the board. And in terms of the resolution, I think maybe you expected the iPhone is much better than the low-cost Raspberry Pi camera. But the dynamic range of both cameras, it's on the same level. For both cameras, we measured a dynamic range of 55 decibel. And then to the color reproduction, in case of a 10 euro camera, is better than in case of the iPhone. Better means, better maybe it's a wrong word. So the color reproduction comes more close to the target. The iPhone is a little bit more colorful, maybe used for the Apple or tuned for the Apple users, iPhone users. And I think here it's important to mention this tuning here we've made by ourselves. So we try, our goal was to come quite close to the test target. And as we investigate these results, we ask ourselves a question: okay, if the dynamic range is the same or is equal to the iPhone, but the colors are more neutral, maybe we can tune the 10 euro camera on the level to the iPhone. And therefore, I show you 3 pictures. That's the picture coming out of the camera without anything. So that's the raw data. Here, that's the picture from the camera with a neutral tuning. So here we try to come close as possible to the colors of the test chart. And here on the right, that's the color of the iPhone. So if you take some photos with your mobile phone, you will maybe more on the left side. So, and there's a live demo at our booth, so you can come next door. And to sum up in the end, I think we tested or we investigate several camera systems. And I think the image quality of the iPhone, that's brilliant, that's great. And our key learnings of this investigations is if you use the same camera sensor, that means not that you have always the same image. It's important that you think about which lens do I use, which driver do I use, and which software settings do I use for the camera chip. And especially in case of the really low-cost camera modules, so 10 euros including lens and the FPC cable. In case of the resolution, it's a bit poor, but in terms of dynamic range and especially in terms of the color reproduction, it is possible to tune a 10 euro camera to the level of an upper-class iPhone. And so let's answer the question. So how well can the low-cost camera's image quality compete with an iPhone? So not in terms of the resolution, but in terms of dynamic range and in terms of especially of the colors. And to give you one message with you to home, it's always important to investigate the entire system. It's not only the camera sensor, it's the lens, the driver, and the software. And for me, my personal learning was especially the driver and the software. Thank you very much for your attention.
Okay, thank you very much for this very interesting presentation and this interesting comparison of image sensors and what it is possible. So, are there any questions? There we go.
Thank you for the talk. You mentioned the iPhone about a price level of 1,000 euros. What are the costs that Apple spends for the camera-specific hardware, like optics, imagers? Did you investigate that as well?
That's a good question.
Good question.
That's a very good question. I have no idea. But I think that's the same here. If you took a low-cost camera module, you also need to investigate in the development that you came on up to the level of the iPhone. That's not out of the box.
It would be very nice if you can request the cost from Apple. But see it as a little homework, and next year you can share it with us. Would be very interesting. Yeah. Okay. Are there any further questions? Oh yeah.
Hi, thank you for the talk. I have a question regarding the resolution comparison. So you said like the iPhone 15, they use like, for example, an edge enhancement filter, but the small MIPI cameras, for example, they didn't use any, so there were not any like specific software on it. So is that even a fair comparison actually? Or did you try, for example, to even further enhance the resolution with some software filters for those small low-cost cameras? Does it make sense, the question?
We made some further investigations. They're not including in the talk. We made some special investigations with a low light. So with 10 lux and we go down to 1 lux. And in such a case, especially for the low-cost cameras, then you see what happens with the noise reduction as well as with the edge enhancement. And to go back, and especially the processor from TI, what we use for this investigation for the low-cost camera, this processor had quite good possibilities for the ISP tuning, and there is an edge enhancement filter included and a noise reduction. And it's also possible here to tune the camera for different light settings. So for example, if you have good illumination, you can use a little bit more the edge enhancement filter, and it's not necessary to use the noise reduction. And for lower light, you can skip the edge enhancement, but use more the noise reduction.
Okay, one last question.
Hi, this is Hendrik with Missing Link Electronics. I would argue that the quality of the sensor is secondary to the post-processing. And one of the things that we see is that if you use transformer nets for post-processing and analytics of the imagery, the quality of the image sensor is absolutely secondary. The question is, what are your findings?
Pardon,
Okay.
the speakers are in your direction, so I have no sound from the microphone from yours.
Okay, yeah, audio is, at least we can hear you. So the question is, what are your findings when using AI, more particular transformer nets, on the impact / the quality of the imaging sensor?
That's a very good question in terms of the AI. We have one project. It's a weed detection system. It's used for farmers to detect weed on the field. And in that case, you have different light conditions because of the weather. And here, the image enhancement, it was a quite important step, because the AI, it's always a question, which data do you use to train the AI? And we had a data set, but we do not cover all weather conditions perfectly and all directions of the sun and the polarized light. And at this specific project, it was important to in the first step, to tune or to enhance the image on the same or nearly the same quality. But it depends on the training data.